In our previous lesson, we understood the meaning of rotation. In today's lesson, we will discuss about various effects of rotation. To understand the primary effect of rotation, we will have to perform an experiment. You need to perform the experiment in a room which has dim light. Now take a globe and mark a particular place, say India, on the globe. And now throw the torchlight on the globe. You will find that the part of the globe which includes India is illuminated by the torchlight, while the other part does not receive the torchlight and is in dark. Now turn the globe. As you turn the globe, you will find that a different part is illuminated by the torchlight while India is in a dark zone. Similarly, as the earth rotates on its axis, different parts of the earth are illuminated in gradual succession. See, here one part of the earth is illuminated while as it turns, a different part is illuminated. Now, the side of the earth that faces the sun experiences day, while the other part of the earth that is turned away from the sun is in dark and experiences night. Now let us draw an imaginary line that will separate the illuminated zone from the dark zone. Now do you know what is this line called? A boundary or a line that separates the illuminated zone or light from darkness or separates day and night is known as the circle of illumination. So this boundary is known as the circle of illumination. It separates day and night. Thus, the primary effect of Earth's rotation is formation of days and nights. Now, days and night occurs in alteration because our earth is not a static body, rather it is always rotating on its axis. So once a part that faces the sun experiences day, and as time passes by it turns away from the sun and experiences night. So rotation of the earth causes days and nights. Now look at this chart. This chart shows the weather update of the city of Jaipur, which is situated in Rajasthan. From this chart, we can find that the temperature varies at different points of the day. For instance, at 11 am, the temperature is 28 degrees Celsius. Then again at 5 pm, which is almost the time of evening, the temperature is 30 degrees Celsius. And at night, that is around 11 pm, the temperature drops to 27 degrees Celsius. Now again around 8 am of the next day, the temperature gradually rises to 28 degrees Celsius. So from this chart, we can understand that the temperature during day is usually very high, while the temperature at night drops or declines. So we can find that there is a variation in temperature of a place during day and night. Let's find out the logic behind this. I just mentioned that the Earth's rotation leads to formation of days and nights. Now apart from this, Earth's rotation also causes variation in day and night temperatures. This is because we not only receive light from sun, but we also receive heat energy from the sun. So a part of the earth that faces the sun receives heat and light energy from the sun. So this part experiences day and has high temperature during daytime. Now as the earth rotates on its axis, we can find that a different part of the earth is now illuminated by the sun, while this part that was facing the sun is now in darkness. So this part of the earth that is now turned away from the sun experiences night and has low temperature, while a different part of the earth's surface which is now facing the sun is experiencing day and high temperature. So from this we can understand that during day we have high temperature because we receive both heat and light energy from the sun, while at night the temperature drops because that part of the earth does not receive heat and light energy from the sun. So by causing variation in day and night temperature, the earth's rotation also helps to regulate the temperature of a place. But if our earth would have been a static body, then a particular part of the earth would always have day and high temperature, while the other side of the earth that is turned away from the sun would always have night and low temperature. Thus, earth's rotation causes variation in day and night temperatures. This is a plan of a house. Can you tell me in which direction the main door of this house is located? Well, in order to determine the direction of the main door, we will have to check the direction in which the sun rises and sets with respect to this house. Well, we know that the sun rises in the east and sets in the west. Now here we can find that the sun rises from the side of the staircase and sets in the side of the balcony. Now if we go back to the plan of the house, then we will find that the staircase is located in the east and the balcony is located in the west. So according to this plan of the house, the main door is in the south direction. Now here we find that the sun rises in the east and sets in the west, whereas we know that our earth rotates from west to east. Then why does the sun seem to rise in the east and set in the west? Let's find out. Imagine you are sitting in a moving bus. If you peep outside the window of the bus, then you will find that the buildings, trees, etc. are moving in backward direction. That is the direction opposite to which the bus is moving. Now, we know that our earth rotates from west to east. So, to an observer standing at the north pole on the surface of the earth, it will seem that the sun moves around him but in an opposite direction, that it rises in the east and sets in the west. So the sun appears to move in an opposite direction to which the earth is moving. Therefore the earth's rotation creates an impression that the sun rises in the east and sets in the west. Now, before we proceed with our lesson, let us try to answer this question. In which direction does the sun set? East, west, north or south? Yes, the correct answer is west. We all know that the sun rises in the east while it sets in the west. So, the correct answer is west. Now, here we have a scene in an amusement park. Here we can see that the boys are having fun on the merry-go-round. But suddenly we can find that a boy slips off the ride and falls on the ground. Now one thing is bothering me. Why did the boy fell outside the merry-go-round and not inside it? This happens because every rotating body creates a force that causes an object to move away or deviate away from the center of the rotating body. So if this point C is the center of the rotating body, then any object on the rotating body will move away from the center of the rotating body, and this force is known as centrifugal force. So due to centrifugal force, an object always moves away from the center of the rotating body. We all know that our earth rotates from west to east. So if you throw a paper plane from the mid of the Indian Ocean towards the north, you will expect it to land exactly to the state of Jammu and Kashmir. But it does not happen. In reality, it deflects to the right and moves towards the North Indian states. Now, turn 180 degree and throw the paper plane towards the south. You will find that the paper plane does not go straight, rather it deflects to the left towards Indonesia. Now, why does this happen? So in the previous video, we saw that the paper plane deflects to the right in the northern hemisphere and to the left in the southern hemisphere. And this deflection happens due to a force which is known as the Coriolis force. So Coriolis force is a deflective force that diverts or changes the direction of any moving mass, just like this paper plane. Now this Coriolis force is same as the centrifugal force that causes a body or an object to deviate away from the center of a rotating body. So in the previous video, we found that the paper plane got deflected due to Coriolis force. Similarly, when our earth rotates, it creates Coriolis force, because of which any moving mass like ocean currents or winds gets deflected. The ocean currents and winds gets deflected to the right or in clockwise direction in northern hemisphere. Similarly, the ocean currents and wind get deflected to the left or they move in anti-clockwise direction in southern hemisphere. See, in this video, we can find that the ocean currents and winds move in clockwise direction in northern hemisphere and they move in anti-clockwise direction in the southern hemisphere, and this happens due to, or specifically this deflection happens due to Coriolis effect caused by Earth's rotation. So in today's video, we understood about different effects of Earth's rotation. The primary effect of Earth's rotation is formation of day and night. That is to say that the part of the earth that faces the sun experiences day, while the other side of the earth that is turned away from the sun experiences night. Thus, each hemisphere of the earth experiences day and night alternatively, and this occurs every day. The second effect of Earth's rotation that we discussed about is variation in day and night temperature. So the part of the earth that faces the sun experiences day and has high temperature, while the part of the earth that is turned away from the sun experiences night and has low temperature. So due to Earth's rotation, different places on earth experiences variation in day and night temperatures. Another effect of Earth's rotation is deflection of winds and ocean currents. We found that as the earth rotates on its axis, Coriolis force is created, because of which the winds and ocean currents are deviated from their original path. Winds and ocean currents move in clockwise direction in the northern hemisphere and they move in anti-clockwise direction in the southern hemisphere. So these are the different effects of Earth's rotation. Well, there are more effects of Earth's rotation that we will discuss in our next video. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million+ questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.